Hello to everyone, especially to the students who enrolled differential calculus this semester. Actually, this topic is most requested to my subscribers that they will have an exam this week. So, he and she told me that, Sir, kindly review us about the limit of a function in a simple way or using L'Hopital's rule. So, my topic today is about limit of a function. So I have series of limits in here. As you notice, we have limit y approaches to 0. Then I have now the trigonometric function. Then number 2 is, sorry, this is algebraic. And then this is trigonometric again. Trigonometric. Okay? Let us solve number 1 first. So I will apply L'Hopital's rule to make it easy. Okay? So in L'Hopital's rule, I'll just copy first the limit. Then y approaches to 0. Then derivative of sine 2y. So derivative of sine, that is cosine. Cosine 2y. Then derivative of 2y, that is 2. Then all over by derivative of 3y with respect to y, that will be 3. And then I'm sure that this will not be 0 for the denominator because this is already 3. But in here, if we will plug in straight away, that will be undefined because the denominator will be 0. So this will be limit y approaches to 0. Then I have a 2 cosine 2y. Then this all over 3. Then plug in the value of y, which is equal to 0. So this will be 2 cosine 2 times 0. Then this will be over y. Over y, that is 3. So 2, that will be 2 times 0, that will be cosine 0 over 3. And we know that cosine 0 is 1, right? Cosine 0 is 1. Then this will be over 3. So 2 times 1, that is 2. Then this will be over 3. So number 1 is 2 over 3. Okay? Then allow me to erase this portion so that I can proceed to number 2. So take note, number 2 can be solved in simple algebraic fraction. So, but in L'Hopital's rule, it's very easy because you have to differentiate, then differentiate. So we know that in a simple way, this will be a limit x approaches to 1. In a simple way, we will apply synthetic division. So take note, the degree is 4. So that will be 1, then 0, 0, then 0, then negative 1. Okay? So x squared, cube, squared, x, and then constant. So assumption will be 1. Our first coefficient will be our basis. Multiply, that is 1. 0 plus 1 is 1. Then 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Take note, in here, the last will be 0. So if not, my assumption is wrong. So 0 plus 1 is 1. 1 times 1 is positive 1. Then this will be 0. So meaning, I have now, factors will be x equals 1, right? To make it a factor form, so this will be x transpose to the left, that will be minus 1, then this will be equal to 0. So I have now, circle brackets, x minus 1. Then I have 4 minus 1, that is cube, right? Plus coefficient of 1, that will be x squared. Then plus x, then plus 1. Okay? So we are now safe. Okay? Safe. Because if we plug in straight away, this will be 0. So this will be x minus 1. Then this will be circle brackets x cubed plus x squared. Then plus x. Then plus 1. Then this will be over x minus 1. Okay? Allow me to erase this portion. So this will be cross out, right? So let us plug in the value of x, which is 1. So 1 cubed plus 1 squared plus 1 plus 1. So this will be 1 plus 1 plus 1 plus 1. So this will be equal to 4. Okay. Let us compare the L'Hopital's rule. So in L'Hopital's rule, so this will be limit x approaches to 1. Then differentiate the numerator and denominator. So derivative of x to the fourth, that is 4x cubed. Derivative of 1, take note, this is minus, 0. Then, derivative of x, that will be 1. Derivative minus derivative of 1, that will be 0. So, this will be limit x approaches to 1. Then, this will be 4x cubed. Then, this will be over 1. So, this is very easy if we will apply L'Hopital's rule. Because it's a simple workings only. So, this will be, we can plug in now the value of x, which is 1. So, 4, 1 cubed. Then, this will be over 1. So, 4, 1 cubed, that is 1. Then, over 1. So, this will be 4 over 1 is equals to 4. So, the same answer. But this is a simple way. Okay? So, it's up to you to compare the two. But my topic today is about L'Hopital's rule. So, I will use this one. Okay? Now, let's proceed to number 3. So, the answer for number 2 is 4. Then, number 3. So, I will use L'Hopital's rule to make it easy. So, this will be equal to limit x approaches to 0. Derivative of second. Derivative of second is secant x times tangent x minus derivative of 1, that will be 0. Okay? And then derivative of x squared, that will be 2x. Okay? So we are so not sure because there is 2x, but we can simplify that one. So this will be limit x approaches to 0. Then I have now secant x tangent x over 2x. Okay? So I can do this one as 1 over 2. Then limit. Then secant x. Then times tangent. So take note, 2 is already outside. Then I have now tangent x over x. Okay? So, this will be x approaches to 0. So, I have now 1 over 2. So, this will be limit secant x. X approaches to 0. So, this will be no tangent x is equals to 1, right? Allow me to erase the portion. So, I'll just write in here. So, I have 1/2. Then, limit x approaches to 0. Then I have now secant x. Then times limit x approaches to 0. Tangent x over x. So take note, this is equal to 1. So I have now 1/2. So plug in the value. So this will be secant. So multiply by secant x. Secant 0. Then times 1. Okay? Second is, this will be 1 over cosine 0. Then times 1. Okay, so this will be 1 over 2. 1 over cosine, that will be 1 over 1, right? Cosine, that is 1. And then this will be multiplied by 1 because limit x approaches to 0. Tangent x over x, that is equal to 1. So I mean this is 1. So 1/2. 1 over 1, that is 1. Times 1. So meaning the final answer is 1/2. Okay? So number 3 is equal to 1/2. Okay? Then let's proceed to number 4. So number 4, allow me to erase this portion. This one also. So number 4. So this will be limit. Again, we will use L'Hopital's rule. So x approaches to 1. Okay, so derivative of sine u. U is this one. Sine u is cosine, right? Cosine, circle brackets, x squared minus 1. Then derivative inside. Derivative inside, that will be 2x minus 0. Then this will be over. With respect to x, differentiate with respect to x, that will be 1. Then minus derivative of a constant, that will be 0. So this will be limit x approaches to 1. Then I have now 2x. Then cosine, circle brackets, x squared minus 1. Okay? So I'll just do this one as my, that will be the first. So 2x cosine, circle brackets, x squared minus 1. And then this will be over 1 minus 0, that is 1. So, okay, so this will be limit x approaches to 1. So I have now 2x cosine, circle brackets, x squared minus 1. So I will plug in the value of x, which is 1. So this will be 2 times 1. Then cosine, circle brackets, 1 squared minus 1. So this will be 2 cosine, 1 squared is 1 minus 1. So this will be 2 cosine 0. So cosine 0 is 1. 2 cosine 0 is 1. So meaning the answer is 2. So number 4 is 2. Then the last number, number 5. So this will be limit x approaches to 0. So apply L'Hopital's rule. So derivative of x with respect to x, so this will be 1. Then plus derivative of sine 2x, that will be cosine 2x. Then derivative of u, that is 2x, this is 2. Then all over by derivative of x, that is 1, minus derivative of sine is cosine. So I have cosine 2x times 2. Or I can write this one as limit x approaches to 0, 1 plus 2 cosine 2x, and then this one is 1 minus cosine, 2 first, 2, then cosine 2x. Okay? So, I will erase this one. So, I can plug in now the value of x, which is 0. So, this will be 1 plus 2 cosine 2 times 0 over 1 minus 2 cosine 2 times 0. So this will be 1 plus 2 cosine 0. Then this will be 1 minus 2 cosine 0. So this will be equal to 1 plus 2 cosine 0 is 1. Then 1 minus 2 cosine 0 is 1. So this will be 1. 2 times 1 is 2. Then this one is 1 minus 2. So this is 3. So this is 3. Then negative 1. So the final answer is negative 3. So for number 5 is equal to negative 3. So let us make our final. So number 1 is 2/3. Then number 2 is 4. Number 3 is 1/2. Number 4 is 2. Then number 5 is negative 3. Okay, that's all. This will help the students for the examination this week. So, a friendly reminder, if you have questions regarding to my discussion about limit of a function using the easiest way for solution, using L'Hopital's rule, you may write your comment or comments at the comment section. Then if you agree with me, please like and share, and do not forget to subscribe to my YouTube channel, Franz Maths TV. Thanks for watching.